Hello friends, welcome back to the CSE. This is our second lecture of our first chapter in distributed databases. So uh, let us see some promises of distributed database system. Distributed database system offers several promises that make them attractive for modern data management needs. Some of the key promises of distributed database systems are improved performance. By distributing the data across multiple nodes, distributed database system can handle large volumes of data and scale horizontally to improve performance. Next is increased availability. With data replicated across multiple nodes, distributed database systems can provide high availability and minimize downtime. Next is enhanced scalability. Distributed database systems can scale horizontally by adding more nodes, making them suitable for large scale applications. Better fault tolerance. With data distributed across multiple nodes, distributed database systems can continue to operate even if one or more node fails. Improved data sharing. Distributed database systems enable data sharing across different locations and organizations, facilitating collaboration and decision making. Next, let us see some common problem areas in distributed database systems. While distributed database systems offer several benefits, they also come with some common problem areas, including data consistency. Ensuring data consistency across multiple nodes is a significant challenge in distributed database systems. Next is data replication. Managing data replication across multiple nodes can be complex and lead to inconsistencies. Next, concurrency control. Managing concurrent access to data across multiple nodes is essential to maintain data integrity. Next, distributed query processing. Processing queries across multiple nodes can be complex and time consuming. Next is security and access control. Ensuring secure access to data across multiple nodes is critical in distributed database systems. Next, let us see architecture of a distributed database management system. The architecture of a distributed database management system typically consists of a node, database fragment, distributed database management system, and a communication network. What is a node? A node is a single computer or processor that stores and manages a portion of the distributed database. Database fragment is a portion of the database stored at a node. The distributed database management system is the software that manages the distributed database, providing features such as data replication, concurrency control, and query processing. Next, communication network. It enables communication between nodes, allowing them to exchange data and coordinate activities. Let us see this high level architecture of a distributed DBMS. First node 1, then fragment 1, node 2, fragment 2, node 3, fragment 3. Then a DBMS which is centralized, which is connected to a communication network. Let us see some alternative design strategies for distributed database system. There are several alternative design strategies for distributed database system, including client-server architecture. In this architecture, clients request data from a central server which manages the distributed database. Next is peer-to-peer architecture. In this architecture, each node acts as both a client and a server, managing its own fragment of the distributed database. Next is hierarchical architecture. In this architecture, nodes are organized in a hierarchical structure, with higher level nodes managing lower level nodes. Federated architecture. In this architecture, multiple autonomous databases are integrated to form a single unified distributed database. Each of these design strategies has its own strengths and weaknesses, and the choice of strategy depends on the specific requirement. Now let us see some important points. What are the four fundamental promises of distributed database system technology? The four fundamental promises of distributed database system technology are improved performance, increased availability, enhanced scalability, and better fault tolerance. Next, let us see what is data independence. Data independence is in the context of a distributed database system refers to the availability to change the physical or logical structure of the database without affecting the application programs that use it. Next, what is the main goal of network transparency in a distributed database environment? The main goal of network transparency in a distributed database environment is to make the distribution of the data across multiple nodes invisible to the user. Now, what are types of data independence? The two different types of data independence are physical data independence and logical data independence. Next, let us see from a DBMS perspective, what does distribution transparency mean? Transparency require. Distribution transparency from a DBMS perspective. Distribution transparency requires that the DBMS manages the distribution of data across multiple nodes without the need for user intervention or awareness of the distribution.